So first of all, I want to thank everybody for participating in this webinar. Over the years that we've had this, actually quite a few years that we've had this, there's been some very, very positive feedback on the overall topic and the information that Howard gives in the entire presentation, to the point where usually we find that people will view it multiple times because it is so data intensive that you almost need to come back and view it a few different times to be able to grasp some of the different topics completely. My name is Jason Spangler. I'm the flooring division manager here at Wagner Meters. I'm responsible for not only the Rapid RH side of the business and concrete testing, but also the small line of wood hand meters in relationship to wood flooring. So everything that we do obviously is wood moisture measurement related, or I should say moisture measurement related. We are going to do some Q&A here, so if you do have any questions, please send them via email so that I can get to as many of them as possible. If for some reason I don't get to your question, please don't hesitate to contact me directly at 800-634-9961 extension 235. At the end of the day, that's what we're really here for. There's going to be a lot of times that you're going to come up with questions maybe after the fact, or think of something down the road, or you have an issue down the road. Definitely utilize us to be able to help you with those potential problems that you're having. So the first question I have is from Nick, and says, what would the relative humidity measurements likely look like over time if there was no vapor retarder beneath the slab? Well, to give you an absolute on that, I would always assume that they have the potential to get to 100%. Because you don't have the ability to say for sure that you're breaking that vapor that's coming from the subbase to the bottom of the slab. So you may potentially have a situation where you test today and things are fine because there's not that much vapor in the moisture vapor in the subbase. But over time it increases, and because you don't have that vapor retarder underneath the slab, the potential for an issue is there. So that's why with older slabs, you start looking at things that are, say 15, 20, 25, 30 years old. If they had a vapor retarder when they were originally constructed, and that is a big if, the potential that the types of material they used on those vapor retarders back then is probably degraded to the point over time that it probably is not effective any longer at this point. The reason why I say if is that back in, I believe it was 2001, the American Concrete Institute, which really is one of the ones that drives specifications on proper construction of a slab that's going to receive some kind of moisture sensitive finish on top of it. There was actually the situation where they had recommendations that vapor retarders were to be placed underneath blotter layers, and then the slab poured on top of that. Well, in 2001, that changed so that they're actually stating that the vapor retarders should be placed directly underneath the slab in most cases when you are putting a moisture sensitive finish on top of it. So hopefully that answers your question. A lot of times people will say, honestly, that if you had a choice of looking at only one thing that you could do on an existing slab, probably doing a core sample would be one of the things on the top of the list, because that would allow you to see if there's an intact vapor retarder there. Question from David. Is it better to test in the winter or the summer? Well, I mean, realistically, David, if you have an intact vapor retarder, it doesn't make any difference. If you have a situation where the vapor retarder is intact and you have service conditions on in the facility that you're working on, and that's the way they're going to be when we say service conditions, that's the way the conditions in the environment are going to be like when they are, when somebody is occupying the space, then technically it's not going to make any difference seasonally when you take the readings. Where it becomes an issue like that is back to the original question that we had from Nick, is that if you have an existing building and it doesn't have an intact vapor retarder, then potentially seasonality could have a huge impact on the readings that you're getting. So it really, when you say what's the best time to test, the best time to test when you have an intact vapor retarder is anytime when you have conditions that are appropriate, interior. But if you have a slab that doesn't have a vapor retarder underneath it, again, it ends up being something where winter and summer could have differences. David, how does raised flooring affect long-term performance regarding dissipating inherent moisture? I'm assuming when you talk about raised flooring, and I could be wrong, but you could be talking about two different things. We could be talking about a gym floor that's a sleeper system, or we could be talking about a floating floor like some of the waterproof products that they're claiming that are out there, the vinyl products. The long-term performance of the product probably isn't that big of a deal. Part of the problem comes down to, and there's going to be more and more of this, I think, that's talked about, is that even though a product may be waterproof and the physical material of the product may last okay, the moisture usually is not dissipating. And so it's sitting underneath that floor. It may come up to the surface, and depending on temperatures and different variances, it may go back into the concrete, but it comes up and comes down. And you may end up in the situation where you end up with mold growth on the backside of this waterproof product, but because there's no adhesive or anything, and there's nothing that allows the moisture to fully escape, you may not even know it. And again, that's just one of those things that a lot of people are talking about out there, that, you know, as these waterproof products become more and more prevalent in the marketplace, non-adhered products, is that going to end up being one of those issues that we have out there? David has another one. Does tile offer a better rigid barrier to moisture? If we're talking like porcelain or ceramic tile, porcelain or ceramic tile has typically been a type of flooring product that has inherently been more moisture resistant. Part of it has to do with the types of mortars, especially if you're doing like a mortar bed or something like that. And I say it used to be. Not to say that it's not still, but the reason why it used to be was because a very, very typical type of tile was a 12 by 12 tile with a 1/4 inch grout line. And you ended up with a situation where the grout line, you had a lot more grout line that you could actually allow some of the moisture to dissipate. As things have moved into larger and larger format tiles and smaller grout lines, you've become more and more moisture sensitive because the moisture that's there is not able to dissipate. So issues with adhering even in the mortar situation have become or increased compared to what they used to be. Looks like we have one from Nick. Have RH meters ever been used to measure if vapor drive from a pool area is getting into concrete slabs either above or below the pool area? Honestly, Nick, I can't tell you for sure. What I can tell you is that we have a lot of these sensors that are used in applications that maybe they're technically not intended for. But, and when I say that, the design on the product itself that we have, and that any of the other ones that would be in line with this presentation we did, are for a very specific ASTM standard. Now, that doesn't mean that the raw sensor, the electronics inside of this device, are not used in a million other applications. It tests relative humidity and temperature. So you find that I'll have people call me and ask me if this thing will test relative humidity in bricks. It'll test relative humidity and temperature in anything. It's just a matter of, with concrete in relationship to finishes, we have some kind of guideline to go off of on what's good and what's bad. when you start talking about brick and brick walls and things like that, trying to understand what's good and what's bad, there's not any empirical evidence out there to say what's good and what's bad. So you can get a measurement, it'll give you relative humidity and temperature, and then it's just going to be a matter of taking that information and actually understanding whether or not it's good or bad. Because there's a lot of people out there that they'll ask, what's quote unquote normal relative humidity for, a slab. And a lot of times when you say 75% would be on the low end, people are really surprised that there's that much humidity in a slab. Keep in mind, if there wasn't quite a bit of humidity in the slab, you would end up with nothing but dust, because the moisture in the slab is really what helps with the hydration, and it's going to stay there. So, at least a certain amount of it. Okay, it doesn't look like I have any other questions. Again, my name is Jason Spangler. My phone number is 800-634-9961, extension 235. And if you come up with any other questions or anything like that, please do not hesitate to give us a call. I'm more than happy to have a discussion, see what we can do to help you out. Thanks a lot and have a great day.